Hello class, this is Mr. Lehman talking to you today about lesson 5 of the weather unit. Here we introduce the absolute zero and the Kelvin scale. We also get into the kinetic theory of matter, which we'll do a separate tutorial on that. Here I'm going to focus on absolute zero and the Kelvin scale. Alright, so what is absolute zero? We talked about absolute zero in class, and we mentioned that absolute zero is the lowest theoretical temperature at which all motion will stop. All atoms are going to stop moving at this theoretical temperature. So no longer will atoms be vibrating in place or moving around in the form of gases, but instead every atom is going to stop moving. It's theoretical. Why is it theoretical? It's theoretical because of this graph here. So let's take a look at the relationship. We learned about in lesson 4 thermal expansion and thermal contraction of matter. We learned that matter, as it's heated, will gain energy. The atoms will move around faster, and that matter is going to expand and take up more space. And we also learned that as matter cools off, it loses energy, the molecules will move more slowly, and matter will contract. And so we're going to focus on 3 gases here, 3 different colored lines, red, black, and blue. And so I got 3 different samples of gas, and I noticed that as I cool them down, temperatures along the x-axis, as I cool down the gases, I noticed that volume, which is on the y-axis, I noticed that as temperature decreases, so does the volume. All 3 lines, all 3 gases converge at the same point. They all reach the x-intercept. They all reach a volume of 0. They all take up 0 space when they reach this temperature, negative 273 Celsius. That is absolute zero. Absolute zero is negative 273 Celsius. Now, why is it theoretical? Why can't we really get to negative 273 Celsius? It's because of this. Gases are made up of atoms. Atoms are matter. Atoms are made of protons, neutrons, and electrons, and atoms have to take up this a little bit of space. So it would not make sense that if I reach this point, that they just wouldn't take up any more space anymore. It wouldn't make sense. And so we can't reach absolute zero. We can get very close to it, but we never can reach a point where volume is equal to 0 because atoms have to take up a little bit of space. So if I come back here and answer this question, why is absolute theoretical? Why is it not a real possibility? It's because volume of a gas or anything made out of atoms cannot be equal to 0. At absolute zero, the volume is equal to 0. So we can't have this. And then if we actually go beyond, absolute zero and went down here, now we're dealing with negative temperatures and negative volumes. And it wouldn't make sense for something to take up negative space. And so what scientists did then, they didn't want to deal with negative numbers anymore, negative temperatures. And so they said, all right, well, the lowest possible temperature is negative 273. So instead of working with negative numbers, let's just make negative 273. Let's just make this 0. And so what they did is they just shifted everything down 273 degrees, and they made absolute zero, 0 Kelvin. 0 Celsius would now be 273 Kelvin. And so we see a relationship here. 1 degree Celsius is still equal to 1 degree Kelvin. So they're equal intervals. It's just Kelvin is equal to Celsius plus 273. Why is this beneficial to scientists? Kelvin eliminates negative temperature. So whenever we plug them into our formula in Charles's law, which we'll learn about in lesson 6, if you had negative numbers, it would just create huge problems, and also the ratios aren't the same either. So we use Kelvin when dealing with gases and dealing with equations in chemistry class. Alright, this is all about lesson 5 here. We'll do lesson 5, part B, coming up next, where we'll talk about the kinetic theory of matter and that atoms are moving and how those atoms move in a sample of gas. Hope this helps. Thank you.